Hello everybody, this is Mrs. Snook with section 5.3, Solving Trigonometric Equations. So we are going to use standard algebraic techniques to solve trig equations, things like adding and subtracting the same thing to both sides. And we're also going to solve trigonometric equations of the quadratic type. So that means we're going to have to do some square roots. All right, let's go ahead and get started. Here's our first trig equation that we're going to do. 2 times the sine of x minus 1 equals 0. So do normal algebraic techniques. We're going to add 1 to both sides, so that gives us 2 sine of x equals 1. And then divide both sides by 2, so sine of x equals 1/2. Now what you're going to do is you're going to grab your unit circle, and we're going to find angles where the sine of x equals 1/2. So when I look at my unit circle, I have sine of x equals 1/2 4. I've got pi over 6 has sine of x is 1/2. And 5 pi over 6. The other thing is, because these functions are periodic in nature, they repeat over and over again, every time I go a complete cycle around the unit circle, I'm adding another answer. So I'm not just going to say pi over 6 and 5 pi over 6 as my answers. I also need to take into account that they repeat. So my answer for x is going to be pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi. N is going to be a whole number. It can be positive or negative, and that's going to then allow you to select answers that are complete laps around the unit circle, complete cycles. So n equals an integer. So with this form, you can do things like pi over 6 plus 2 pi, pi over 6 plus 4 pi. You can also do pi over 6 minus 2 pi. So this notation allows you to represent all the possible answers to this equation. Let's do another one. So we're going to collect like terms, and we're going to find all the solutions in the unit circle. So notice I have a sine x here and a negative sine x there. I want to combine those together, so I'm going to add a sine x to both sides. I get 2 times the sine of x plus square root of 2 equals 0. And now I'm going to subtract square root of 2 from both sides. So 2 sine of x equals negative square root of 2. And then divide both sides by 2. So sine of x equals negative root 2 over 2. So I also want to point out that what I'm doing is I'm isolating the sine x. I'm treating that like it's the variable until the very end. Now I'm going to go to my unit circle, and I'm going to find those places where sine of x is negative square root of 2 over 2. And I have one of them at 5 pi over 4. And I have another one at 7 pi over 4. And since it says to find all solutions in the unit circle, I'm not going to keep going around. I'm just going to stay between 0 and 2 pi. So therefore, these are my answers. I just have these two answers this time. All right, here's one where I'm starting to get some quadratics in here. Look at that, I've got a tangent squared. So I'm going to have to take a square root when I'm done. So isolate your tangent square term. So just pretend that that's like an x squared. So the first thing I'm going to do when isolating is I'm going to add 1 to both sides. So I get 3 times tangent squared of x equals 1. And then the next thing I'm going to do is divide by 3. So tangent squared of x equals 1 over 3, 1/3. This is where I do the square root. I'm going to square root both sides. So tangent of x is going to equal plus or minus square root of 1/3. Remember, the square root wasn't already in the problem, so when you put in the square root, you take both positive and negative. And I'm going to then do some simplifying. I can square root my numerator, that's just 1, and the denominator is just square root of 3. Let's rationalize that. So I get plus or minus square root of 3 over 3. So what I'm trying to do is go to the unit circle, and a tangent of x, recall that, has a tangent of x's period is pi. So I'm just going to look at the unit circle from 0 to pi. If you recall from chapter 4, you would do pi over b. B is 1, so you just get pi for your period. So I'm just going to look from 0 to pi on my unit circle. I'm going to find places where the tangent of x is square root of 3 over 3. It's probably easier to think of it as looking for 1 over root 3. So I'm going to find places where my numerator for the sine has a 1, and the numerator for the cosine has a root 3, because then when I do sine over cosine, I get 1 over root 3. So when I do that, I have pi over 6. And I have 5 pi over 6. So those are the two places. And then it doesn't say just stay on the unit circle. So what I'm going to do is I'm going to find all of the solutions. So what I'm going to do is add multiples of the period. So x is going to be pi over 6 plus n pi. And it's going to be 5 pi over 6 plus n pi. Again, n is an integer. So this is going to cover all of our possible solutions. All right, now we're going to do some factoring. So the first thing I want to do when I'm factoring is I want to have everything on one side of the equation. So I need n equals 0 over here. To do that, I'm going to subtract 2 cotangent of x from both sides. So cotangent x, cosine squared x, minus 2 cotangent x. Okay, so what can I pull out for factoring? I can pull out a cotangent of x. So cotangent x times cosine squared x minus 1 equals 0. Now we're going to use the same tool that we did when solving by factoring with polynomials. We set each factor equal to 0. So cotangent x equals 0. Cosine squared x minus 1 equals 0. My cotangent of x equals 0. That's already ready for me to go to my unit circle. Cotangent is x over r, so I'm looking for x over y. I'm looking for places where my x equals 0. So I have pi over 2. And I'm also going to handle the cosine squared x minus 1. So cosine squared x, add 1 to both sides. Now I'm going to take the square root of both sides. So cosine x equals, oops, my app crashed on me there. And I also see a mistake. Before I go further, I'm going to fix this. That's a 2, right? So now I need to square root 2 on both sides. Again, take both plus and minus. So cosine of x equals plus or minus square root of 2. So one thing I want you to notice is square root of 2 as a decimal is approximately 1.4. Cosine only goes between -1 and +1. So this one is no solution. So I can't get anything from my cosine squared x minus 2. But I do have an answer from cotangent x equals 0. We said it was pi over 2. Bear in mind that cotangent also is periodic and repeats. The period is pi. So I'm going to add an n pi to get all of my answers. Okay, we're going to do some factoring now. We're going to find all the solutions in the unit circle. So that means I'm going 0 to 2 pi. And I have 2 sine squared x minus sine x minus 1. And I need to factor that. And one thing I like to do, this is a nice little tool in my toolbox that makes it easier, is I like to do a change of variable. So I'm going to change a variable. And instead of thinking in terms of sine x, I'm going to say g equals sine of x. And then when I do that, this is what I get. I get 2g squared minus g minus 1 equals 0. That looks just like the polynomials we factored back in chapter 2. So let's factor this with slip and slide. I'm going to slip my 2, so I have g squared minus g minus 2 equals 0. Factor. G minus 2, g plus 1 equals 0. Now I've got to undo what I did, so I'm going to slide my 2. And I get g minus 1 times 2g plus 1. So now let's go back to our original variable. Let's go back to sine of x. So when I do that, I now have sine x minus 1 times 2 sine x plus 1 equals 0. Okay, do like we did before. Sine of x minus 1 equals 0. 2 sine of x plus 1 equals 0. So I'm going to keep on solving this equation. Sine x equals 1. Go in my unit circle. Where does sine of x equal 1? That's going to be where y equals 1, and that's at pi over 2. Let's see if it's 1 anywhere else. I've got a -1 at 3 pi over 2. That doesn't count. So I just have pi over 2 for that one. And then over here, I'm going to solve this one. I get 2 times the sine of x equals -1. Sine of x equals -1/2. So now look at your unit circle. Where do you have sine of x equals -1/2? I have it at 7 pi over 6. And I also have it at 11 pi over 6. So those are my 3 answers. I only have 3 this time. And that's it for today's lesson. Thank you for watching and have a great day.